The first equation we're going to solve is cos x equals minus 0.2, and we're going to do that for values of x between 0 and 360. So we're covering all four quadrants. So the first task is to find where the angle x degrees is, which quadrant is it in. X is in, and here's the quadrant diagram. In my previous video explained how to work this diagram. Cosine being negative, in the first quadrant 0 to 90 degrees, all three trig functions, sine, the cosine, the tangent, they're all positive. That's no good. Second quadrant between 90 and 180, the sine only is positive, the cosine, the tangent are negative, and we do want the cosine being negative, so that's a quadrant that x degrees could be in. Third quadrant angles between 180 and 270, only the tangent's positive, so the cosine, the sine are both negative. Cosine negative, again, that's a situation we're interested in. So x degrees could be a third quadrant angle. Fourth quadrant between 270 and 360, only the cosine's positive, so that's certainly not one we're interested in. So the second and third quadrant are the two quadrants that x degrees could be in, that angle could be in. So x is in second or third quadrants. Now, in the previous video, I showed you how the first quadrant angle, that's in this case the one where the cosine of x degrees is positive 0.2, the first quadrant angle, how it's related to the second and third quadrants. To get the second quadrant angle, you do 180 degrees minus the first quadrant angle. And to get the third quadrant angle, you do 180 degrees plus the first quadrant angle. So we now really have to find the first quadrant angle to make any progress. The first quadrant angle is, so we need a calculator, and let's just clear the display on this one. 0.2, positive 0.2, we're in the first quadrant now, so we want to know the angle whose cosine is positive 0.2. Now that involves the cosine to the cos minus 1 button. You might know it as the inverse cosine or second function cosine in your calculator. So pressing this will give me the angle whose cosine is 0.2. However, the mode is important. I don't want to be in radian mode, I want to be in degree mode. You'll know with your own calculator how to change mode between degree and radians. So which angle gives me a cosine of 0.2, and we're thinking in degrees, it's 78.46. 78.46, and so on. So that's the dots here just mean that I haven't rounded the angle at this point. So first quadrant angle is 78.46 degrees roughly. And we know that the angle to solve this equation is in the second or third quadrants. So I now have all the information I need to solve this equation. X would be equal to second quadrant angle 180 minus the first quadrant angle of 78.46 ... or third quadrant angle 180 plus 78.46, and so on. So I need to do a calculation now. Let's call up the calculator again. And this time, if you notice, each of these two calculations involves the angle 78.46. We really don't want to keep calculating that again. Remember that that came from 0.2, the angle whose cosine was that. We don't want to keep doing that calculation, so let's put that in the memory. Your calculator will also have a memory in button. That M tells me that the calculator is now remembering that. If I do the clear, not the all clear, the all clear would wipe the memory out, but the clear button wipes the display out. And memory recall, or RM, and some calculators, there is a button that will recall the memory. There's the first quadrant angle. So clear the display, recall the first quadrant angle, clear the display. So we're using the memory in this calculator, and we want to calculate 180 minus this first quadrant angle. So 180 minus the first quadrant, recall the memory, first quadrant angle, and that equals, there it is, 101.53. So 101.53, and so on. No approximation yet. Or, and we now want to go and do this calculation, 180 plus the first quadrant angle. So I'll clear the display, 180 plus recall memory, there's the first quadrant angle, and that gives me 258.46, and so on. No approximation at this stage. So let's get rid of the calculator now. And therefore, and normally the accuracy we write answers when we're working with angles is usually 1 decimal place. So we have 101.5 degrees or 258.5 degrees to 1 decimal place. Actually, I shouldn't use degree signs in there. So these are the two solutions, a second and a third quadrant solution to this equation. The next equation we're going to solve is 2 tan x minus 3 is equal to 0. And again, the angle can range anywhere from 0 up to 360. That covers all 4 of the quadrants. Now in this case, the equation needs a bit of rearrangement. We have to get this into a form that says tan x equals a number. So let's get rid of this minus 3 by doing the opposite, adding 3 to both sides. That would leave us tan x, 2 tan x, and adding 3 to this 0 gives us 3. Get rid of this times 2 by doing the opposite, dividing both sides by 2. That would give us tan x equals 3 over 2, or 1.5. Which quadrant is x degree in? Tan positive. Let's look at our quadrant diagram. Tangent positive, they're all positive in the first quadrant. Sine, cos, tan are all positive for any angle in the first quadrant between 0 and 90. So yes, we're interested in that. That's a possibility. Second quadrant, only the sine's positive, so the tan will be negative. That's not of concern to us. We rule that one out. Third quadrant, the tan is positive. Sine and cos are negative. So yes, that's a possibility for x degrees, an angle between 180 and 270. Fourth quadrant angles between 270 and 360, only the cosine of them is positive. So tan would be negative. That's not a possibility in this case. So first and third quadrants. X is in the first or third quadrants. And again, as we did in the last example, we need to find out the first quadrant angle. And to do that, we'll call up the calculator. And to find the angle whose tangent is 1.5, we'll type in 1.5. Make sure we're in degrees. Tan to the -1, or inverse tan, or second function tan, is the button that you'll use. So pressing this gives me the answer to what angle has a tangent that's 1.5. There it is, 56.3. So first quad angle is 56.30, etc. degrees. So let's get rid of the calculator. So let's move on with this. X would therefore be equal to the first quadrant angle. We are allowed this 56.30, or in the third quadrant 180 degrees plus the first quadrant angle. So 180 plus 56.30. And we now therefore have to calculate 180 plus 56.30. Let's store this memory in. We've stored that. So 180 plus, recall the memory, this 56.3, that equals 236.30 degrees. So therefore X is equal to 56.3 to 1 decimal place, or 236.3 to 1 decimal place. So these are the two possibilities for the angle in this, for this equation to be true. First quadrant and third quadrant values. So the last equation we're going to solve is 3 sine x plus 2 is equal to 0. And again, x will range from 0 to 360. So a bit of rearrangement. We'll need to subtract 2 from both sides. That'll leave me on the left with 3 sine x. 2 from 0 is minus 2. To get rid of this, we'll divide both sides by 3. Always keep equations balanced. Do the same to both sides. So sine of x is minus 2/3. Which quadrant could x be in? X is in, here's our quadrant diagram. Sine is negative, they're all positive. Sine is positive. Here only tan is positive, so sine is negative. Here only the cosine is positive, so the sine is negative. So quadrants 3 and 4. So x is in third or fourth quadrants. Now to get into the third quadrant, it's 180 degrees plus whatever the first quadrant angle was, and to get into the fourth quadrant it's 360 all the way around minus the first quadrant angle. So to find the first quadrant angle, first quad angle is, and in this case we have to say for the first quadrant angle, what angle has a sine that's positive 2/3. Remember in the first quadrant it's positive 2/3. So let's call up the calculator and clear everything there. And this time we want negative 2/3. So plus minus gives a negative, but that'll only happen after I've got 2/3 in. So 2 divided by 3, there it is, and make it negative. So this is the value that I want to know the angle whose sine is this value. So that's my sine to the -1 button, checking I'm still in degrees, and sine to the -1 gives me this minus 41.8. Now what I did wrong there was put a negative in there. I shouldn't have done that. For my first quadrant angle, I always want to do inverse sine, in this case, of a positive quantity. We ignore the negative, or we make this positive to find the first quadrant angle. So let's clear it all and start again. So 2/3, 2 divided by 3 is equal to there. There's 2/3, 0.66 repeater. And my inverse sine, the angle whose sine is this in the first quadrant, is 41.8. So let me put that down, 41.81, and so on. So that's my first quadrant angle. So we'll get rid of the calculator. All the information is here. This means that x is equal to third quadrant 180 plus the first quadrant angle of 41.81, or fourth quadrant angle 360 minus 41.81. We now want to do these calculations, and 41.81 is important. Remember that came from the 2/3, 2 divided by 3, and what angle had a sine that was that, 41.81. So I don't want to keep repeating that calculation, so let's store it in the memory and try 180 first for the third quadrant angle. 180 plus, recall the memory, that equals 221.81, or 360 minus, recall the memory, and that gives me 318.18. So we'll get rid of the calculator and let's approximate this. So x is equal to either 221.8 or 318.2 to 1 decimal place. Third quadrant and fourth quadrant angles.